So, what is a programmable logic controller? Commonly referred to as a PLC, it's a robust digital computing device used for controls and automation. The PLC receives input signals, processes the input data, and based on program instructions, it makes decisions and provides outputs required to control the equipment. As the name implies, it is programmable. The instructions are programmed using a suitable programming language to create a user program that is then loaded to the PLC memory. When working in industrial automation and referring to programmable devices, other acronyms like PAC and IPC will come up. These are Programmable Automation Controllers, PAC, and Industrial Personal Computers, IPC. These devices have similarities to PLCs, like handling inputs, processing instructions, and providing outputs, but there are subtle differences. PAC is a term applied to devices with more advanced features than common PLCs. Allen Bradley Control Logics is an example. Rockwell calls this platform a PAC, and it has some fancy stuff. There's built-in motion control, there's a 32-bit bus, but in time, PLC development tends to catch up. So sometimes it's hard to tell the difference between PAC and PLC. IPCs run operating systems much like normal personal computers. This would include versions of Windows or Linux. This makes IPCs very flexible with many software tools that can be loaded. Sometimes they have a display. An example could be an IPC that controls a machine and runs visualization software to provide a human-machine interface. A control display with a touchscreen. For the scope of this learning series, we will be referring mostly to PLCs. Okay, let's take a look at the history of electrical control. To better understand the benefits of PLCs, it helps to understand the state of electrical control before PLCs. So it is helpful to review relay logic. Before PLCs were mainstream, controls were hardwired. These hardwired systems consisted of control panels and were filled with switches and relays. It was common to use relays to make simple logical control decisions. This method of implementing logic in electrical control circuits, based on relays wired in a particular formation, is known as relay logic. So relay logic was common for electrical control until the PLC is invented in the late 1960s. Since then, they have become commonplace for industrial control. PLCs replaced hardwired relay logic with software-based programmable logic. So the advantages of PLC? More cost-effective for controlling complex systems. Flexible and can be applied to control other systems quickly and easily. When you think about it, when a factory retools, instead of rewiring banks and banks of control relays, you can simply reprogram the PLC. They are programmable and computer-based, so this allows for more sophisticated control. They have built-in computerized troubleshooting aids that makes programming easier and reduce downtime. And at the end of the day, they are very reliable. Ladder logic is a popular PLC programming language designed to resemble ladder schematic drawings. You can see the electrical drawing on the left and the PLC code in ladder logic on the right. It is apparent that ladder logic is designed to reach people who already understand electrical drawings.